A train is moving at a constant velocity when it begins to speed up at a constant acceleration, as shown in the graph on the right. What is the acceleration of the train? So we have another motion graph. The horizontal axis is time in seconds, and the vertical axis is velocity in meters per second. We see the train starts moving at a constant velocity where the line is flat, and then it increases at a constant rate. The problem is asking us to find the acceleration of the train. So how do we find that from this graph? Well, the slope of the velocity time graph is acceleration. Again, if we were using calculus, we'd say acceleration is the derivative of velocity with respect to time. So what points are we going to use to find the acceleration? The problem didn't tell us when the train is accelerating, but we can see that during the first part where the line is flat, the velocity is constant, and then during the second part, when the velocity is increasing, the train is accelerating. So we want to find the slope of the line during the second part when the velocity is increasing. So which points should we use to find the slope? If the line doesn't start or end at a grid point, we need to choose points where the line does cross grid points so that we get whole numbers. We can see the line crosses through these three grid points where the time and velocity are whole numbers. In general, it's best to choose 2 points that are as far apart as possible. If the line isn't really crossing at those exact grid points, then using a larger range will reduce the amount of error that we get when plugging in the numbers. So let's use these 2 points. We could just reference the graph, but let's write down that the initial time is 4 seconds, the initial velocity is 5 meters per second, the final time is 8 seconds, and the final velocity is 15 meters per second. And the problem is asking us to find the acceleration. Here's the equation for the slope of a line, and since we're working with a velocity time graph, let's replace y and x with v and t. Notice that this is the same as the equation for acceleration, which is why the slope of the velocity time graph gives us acceleration. So, using this equation, the slope is the change in velocity over the change in time. We plug in 15 meters per second for the final velocity, 5 meters per second for the initial velocity, 8 seconds for the final time, and 4 seconds for the initial time. And we find that the slope and the acceleration is 2.5 meters per second squared. Does that answer make sense? We can see the velocity is increasing, so the acceleration should be positive. We also got the right unit for acceleration. 2.5 meters per second squared means the velocity increases 2.5 meters per second after every second. So it'll increase 5 meters per second every 2 seconds. And that's what we see in the graph, so this checks out.